Okay, so to answer this question, I have copied the circuit from the question and I have divided the paper into three parts, which includes the capacitance C, the charge Q, and the potential difference V. To answer the first question, to calculate the effective capacitance, we need to first simplify our circuit, and from the circuit we can clearly see that there are three capacitors that are arranged in parallel, C2, C3 and C4. So after we combine the three capacitors, we will get two capacitors arranged in series, which are C1 and C2, 3, 4. To calculate the effective capacitance for the parallel combinations, we have to use the total capacitance in parallel, C2 plus C3 plus C4. Next, substitute all the values. And we will get the effective capacitance for the parallel combination equals to 47 microfarad. Next, to calculate the combination of the series capacitors, we will get a total capacitance or C effective. And to calculate the effective capacitance for a series combination, we use 1 over CE equals to 1 over C1 plus 1 over C2, 3, 4. Do the substitution. And we will get the effective capacitance, which is equals to 8.25 microfarad. So that answers question A. For next question, we want to calculate the charge on each capacitor and voltage across each capacitor. So what we have to do, since we already know the effective capacitance, 8.25 microfarad, and we are given the voltage across AB, which is 20 volts, we can calculate the CQ total by using C effective multiplied with voltage AB. So the value of C effective can be calculated from the first column C. We'll do the substitution. And from there, we will get the total charge in the circuit, which is 1.65 times 10 to the power of negative 4 coulomb. Alright, in order to get the individual charge on each capacitor, we have to go one step backwards from our circuit. And in the circuit, we have two capacitors that are arranged in series. And according to the concept for series combination, we know that the Q charge is the same for all capacitors. Therefore, we will get the value for Q1 that is equals to 1.65 times 10 to the power of negative 4 coulomb. Okay, so we have answered for Q1, and we also know that Q234 is also equals to 1.65 times 10 to the power of negative 4 coulomb. From the value of Q1, we can get the voltage across capacitor 1. So V1 is equals to Q1 over C1. So we use the value that we have calculated from the second column, substitute the values, don't forget to add the prefixes for the capacitance and the charge. So the voltage across 1 is 16.5 volts. And we know that the two capacitors are arranged in series, and for series combination, the total voltage is the sum of all the voltages across each capacitor. So from there, we can get the value of V234, which is equivalent to 3.5 volts. Okay, so to calculate the voltage across each individual capacitors, we have to go one step backwards for our circuit. Okay, so by using the value of V234 here, we know that for parallel combination, the voltage across each capacitors are the same. Therefore, we will know the value for V2, V3 and V4, which is equivalent to 3.5 volts. Next, by using the value of V2, V3 and V4, finally we can calculate the charge in each capacitor. So let's start with Q2. To calculate Q2, we use C2 times V2. So we do the substitution, and we'll get Q2 is 1.75 times 10 to the power of negative 5 coulomb. Okay, do the same steps for Q3, but remember to substitute the value of C3 and V3. And we will get the answer for charge 3 is 1.05 times 10 to the power of negative 4 coulomb. And lastly, we have Q4. So we use C4 multiply with V4. Do the substitution. And that will give us the answer for Q4 is 4.2 times 10 to the power of negative 5 coulomb. So there you have it, all the answers from question A, the C effective, the charge on capacitor 1, the voltage on capacitor 1, the charge on capacitor 2, 3 and 4, and also the voltage for 2, 3 and 4.